Hello! Today we will continue to learn general embryology. Part 4. Differentiation of 3 germ layers and formation of embryonic body. Differentiation of 3 germ layers. During the 4th to 8th week, the 3 germ layers gradually differentiate to form the primordium of various organs. Differentiation of ectoderm. After the formation of the notochord, the ectoderm of the dorsal midline was induced to thicken and become plate-like, which was called nerve plate. This part of the ectoderm, also known as neuroectoderm, which forms the nerve plate, while the rest is often called the superficial ectoderm. The nerve plate grows with the growth of notochord, and the head part is wider than the tail part. Then, the central part of nerve plate is depressed along the long axis to the direction of the notochord, forming a nerve groove. The 2 sides of the groove are called nerve folds. The nerve folds on both sides are close to each other in the middle of the neural groove and fuse, and progress to both ends of the head and tail. At last, there is an opening at both ends of the head and tail, which are called anterior and posterior neural foramen, respectively. They are closed in the 4th week, making the neural groove completely closed as neural tube. The surface ectoderm on both sides of the neural tube close to the dorsal side of the tube and fuse, so that the neural tube is located in the deep surface of the superficial ectoderm. Neural tube is the original basis of central nervous system, and the superficial ectoderm will differentiate into epidermis and skin appendages. Look at this slide. These 2 pictures shows the cross-section of embryo. The amniotic sac above and the yolk sac below are not shown. In the upper one, the blue part is neural plate, and the notochord is in the center of the embryo, and in the lower one, you can see the process of neural fold formation and the neural groove. In the process of the neural groove closing into neural tube, the cells at the lateral edge of the neural plate also enter the dorsal side of the neural tube wall, and soon migrate out of the tube wall, forming 2 longitudinal cell cores located at the dorsal side of the neural tube, called the neural crest yellow part. Neural crest is the primordium of peripheral nervous system. These 2 pictures are cross-section of embryonic specimens. The upper one shows the formation of neural groove and the neural fold on both sides of the neural plate. The following shows the formation of the neural tube, noting that the notochord below and the superficial ectoderm above the neural tube have fused together. This animation shows the thickening of the nerve plate, the middle depression forming the neural groove, and the 2 sides of the bunch forming the neural fold. Note that the black structure under the neural plate is the notochord. This is a cross-section pattern of the embryonic body. From the top to the bottom are the surface ectoderm, the neural crest on both sides of the neural tube, and the notochord below. Neural crest will differentiate into brain ganglia, spinal ganglia, autonomic ganglia, and peripheral nerve. Some cells also migrate into adrenal primordium and differentiate into medullary chromophene cells. In addition, some of the cells migrated into the epidermis and differentiated into melanocytes. And the neural crest cells in the head also participated in the formation of bone marrow and connective tissue in the craniofacial region. This is the surface view of the embryonic disc. Remove the amniotic sac and show the back of amniotic disc. Through chimerism, we can find that the number of somates in the left is small, which means that the time is earlier than that in the right. In the left, we can see that the middle of the nerve groove has been closed to form a part of a neural tube, while the two sides of the head and tail have not been closed. In the right picture, most parts of the neural tube have been formed, and only in the head and tail there are anterior and posterior neuropore. The neural tube can be differentiated into brain and spinal cord, pineal gland, neural hypophysis, and retina. If the anterior and posterior foramens are not closed, they will lead to anencephaly and myeloschisis, respectively. In this slide, picture A, B, and C show you the front view, side view, and back view anencephaly with myeloschisis. This photo is a baby with anencephaly. Superficial ectoderm. The surface ectoderm will differentiate into the epidermis and its appendages of skin, as well as the dental enamel, corneal epithelium, lens, inner ear membrane labyrinth, adenoid hypophysis, salivary gland, oral cavity, nasal cavity, and epithelium of lower anal canal. This shows the different stages of the development of the skin appendages. Differentiation of mesoderm. The mesoderm cells on both sides of node cord proliferated rapidly and differentiated into paraxial mesoderm, intermediate mesoderm, and lateral mesoderm from inside to outside. Mesoderm cells usually form mesenchyme first and then differentiate into connective tissues, muscle tissues, and blood vessels. Paraxial mesoderm. The mesoderm cells on both sides of the node cord proliferate rapidly, forming a pair of longitudinal cell cords, namely paraxial mesoderm. It then splits into meso cell masses called somas. The somas are in pairs from the neck to the tail and gradually increase. At the 5th week, the somas were all formed, 42 to 44 pairs in total. The somas are mainly differentiated into dorsal, dermis, skeletal muscle, and exoskeleton, such as spine. Most of the node cord will degenerate and disappear, and only the nucleus pulpus remains in the intervertebral disc of the spine. Intermediate mesoderm, located between paraxial mesoderm and the lateral mesoderm, it differentiates into the main organ of urinary and respiratory systems. Lateral mesoderm. The outermost part of the mesoderm, there are some small cavities in the inner part, and then it fills into a large intraembryonic cavity, which is connected with the extraembryonic cavity. The lateral mesoderm is divided into two layers. The mesoderm adjacent to the ectoderm is the somatic mesoderm, which mainly differentiates into the dermis of skin, skeletal muscle, skeleton, and blood vessels of the chest, abdomen, and the limbs. The mesoderm adjacent to the endoderm is the splenic mesoderm, which covers the primitive digestive tract formed by the endoderm and differentiates into the muscle tissue, blood vessels, connective tissue, and the mesothelium of the digestive and respiratory systems. In this slide, you can see paraxial mesoderm, intermediate mesoderm, and lateral mesoderm, which includes somatic mesoderm and splenic mesoderm. In this animation, pay attention to the change of mesoderm, which is differentiated into three parts: paraxial mesoderm, intermediate mesoderm, and lateral mesoderm. Differentiation of endoderm. The endoderm is enveloped by the human embryo to form the primitive digestive tract, which will differentiate into the epithelium of the digestive tract, digestive gland, respiratory tract, and lung below the throat, as well as the epithelium of the middle ear, thyroid gland, parathyroid gland, thymus, bladder, and other organs. From the left to right, this slide shows the appearance, longitudinal and transverse changes of the embryo. In the C2 and D2 pictures, we can see the yellow part, which is wrapped in the embryo, which is the primitive digestive tract, and the middle part is connected with the yolk sac below. From the head to the tail, the body cavity will differentiate into pericardium, pleura, and peritoneum. Well, let's use this slide to summarize this section. Can you tell me which germ layer the organs in the three pictures are developed from? 5 seconds. I think you have the answer. From the left to the right, nervous system, ectoderm, skeletal muscle, heart, kidney, gallbladder, mesoderm, the epithelium of digestive and respiratory system, endoderm,